Okay, if you see here, okay, I have put in the standard normal distribution table here. Okay, I put this one, label it as exam because this is our real SPM paper I took from there. Okay, so wait. Okay. Okay, if you have a textbook, turn to page 173. Okay, let us continue in the same book. Okay, so this is your index for today. That means the probability of an event. Okay, so today is what? 16. Okay, so we refresh a little bit. We recall a little bit what we have learned yesterday. Okay, look at this example. Okay, how we use the Z-score formula. Okay, so now we are going to use this Z-score formula inside the probability. Okay, so you see the Z-score formula inside the probability. Okay, so you see if an event is normally distributed, then its probability can only be determined if its normal distribution is converted into standard normal distribution. If you don't convert it, you see the tables there is only one table, which is referring to this standard normal distributions. Okay, we don't have other tables that have a different mean and different standard deviations. So if you want to refer to the table and get the probability, which is the area under the curve, okay, what you have to do is by this way, the only way, okay, convert it into this standard normal distributions, okay, no other way, okay. But actually some advanced calculator, if not mistaken, the white color one, anyone having the white color calculator, I think they can do, okay, you don't have to convert into this standard normal distribution. They can key in for any normal distribution, for any mean, any standard deviations, and give you the answer for the probability or the area under the curve. Okay, but the problem is you know, this is during the exam or what okay, we need to see your working. So you got no working of converting the normal distribution to the standard normal distribution. There's no mark will be given, no. Okay, so you can't just use that type of calculator and then give you the final answer one straight away. Cannot. Okay, you still have to do the step. You still have to do convert, okay, into a standard normal distribution. Okay, you still have to show the step. Okay, so for example, to find the probability for a continuous random variable x that occur between A and B, this one you have learned, okay, if from A to B, okay, then we write in this way. Okay, then you want to convert it into a standard normal distribution. So you do, okay, follow the z-score formula. Okay, z is equal to, okay, x minus mu divided by the sigma. Okay, so you follow this. Okay, do minus mu divide sigma to every of this. Okay, so you see the A minus mu divide sigma. Okay, the X minus mu divide sigma. The B minus mu divide by sigma. Okay, so for every of this, you do the same thing. Okay, and then next line, you can write this one as Z already. Okay, because this x minus mu divided by sigma, its memang is z. Okay, then you can write as z already. Okay, then this one, normally the a maybe is a number, so you can get the answer for this, and then this one also. Okay, then read from the table. Okay, so we see this. This one you learn already, okay. If finding the probability means what? You finding the area under the curve, okay, from A to B. Here is the A and here is the B. It means you are finding the area, okay, this area. When you say you want to find the probability, means actually you are finding the area, okay, under the curve from the x equal to A, okay, to x equal to B. Okay, after standardize it, okay, so this is a standard normal distribution graph. Okay, so you see the mean is at the 0. Okay, then okay, the A now shift to A minus mu over sigma, and the B shift to B minus mu over sigma. Okay, but it's the same thing. Okay, you are referring to this area under the curve. Look at this example. Okay, for this, I want you to copy this one. Okay, after you write your index and then the small title, okay, you copy this one. And we look at this example. Okay, the length, okay, of a type of screw produced by a factory can be considered as a normally distributed. Okay, you see, here they don't say it standard normally distributed. So this is not the standard normal distribution. Okay, with a mean of 10.6, standard deviation 3.2. Okay, so you write out the mean, the mu, okay, standard deviation, the sigma 3.2. Represent the probability that a screw not randomly chosen from a factory has a length between 8.4 and 13.2. Probability, okay, so P, okay, then the screw, okay, the length between 8.4, 13.2, 8.4, 13.2, okay, so now where Z is a standard continuous random variable, so they want you to change it into Z score, okay, so this one, still remember, follow this, just now what I asked you to copy. Okay, so you do minus mu divide by sigma to every terms here. Okay, so you minus mu, okay, which is minus 10.6, okay, divide by sigma, divide by 3.2 for this 8.4, 13.2, and as well as for the x. But for the x, you don't write minus 10.6 and then divide by 3.2, no point, because this one you going to write it as z only. Okay, so this one you remain as a minus mu over sigma, or one shot actually here you can straight away write z. Okay, but remember your 8.4, your lower boundary, and the upper boundary here 13.2, you got to minus mu divided by sigma. Okay, so here minus 10.6 divided by 3.2, this is what you get, and then here you minus 10.6 divided by 3.2, this is what you get. Okay, so for this example, it only wants you to write out the probability. Okay, represent the probability. Okay, in a Z score. Okay, so until here only we do. Okay, we no need to proceed. Okay, next we're going to learn. Okay, how we going to get the value, get the answer for this. Okay, after you change it into Z score, how do we get the answer? Okay, from the table given. Okay, this is how the table look like. After I will open the soft copy as well. Okay, but before that, okay, the whole idea. Okay, we see here the probability of a Z score of a standard normal distribution, such as okay, P Z equals to smaller z, okay, can be determined by using the standard normal distribution table. This type of table. This table is formulated based on the concept that the probability of a normal distribution is the area under the curve. Okay, this one you know already. property is the area under the curve, and the total area under the curve, under the graph is 1. These are also yesterday you have learned. The total area is 1. Okay, since this graph is symmetrical, this one yesterday also you learned. Okay, the graph is symmetrical, and then 50% okay below the mean, 50% above the mean. Okay, here the mean is 0. Therefore, the probability for z bigger equals to 0 or without the equal also the same is 0.5. Okay, because the total is 1, so you divide it into 2 parts. So 0.5 for bigger than 0. Okay, for smaller than 0 is another 0.5. Okay, so when this part for z for probability for z equal bigger than 0, okay, is 0.5, and the numeric table only give the value of the area to the right, starting from 0.5, which is for z for probability for z greater than 0. Okay, this is the meaning. Okay, you see, it starts from 0.5. Okay, when z is 0. Okay, so this one means, okay, if your graph here is the 0. Okay, for z is greater than 0, area under the graph. Okay, here, this part. Okay, here is the area is 0.5. This is the meaning. It starts from here. Okay, so for 0.1, what's the meaning? Okay, the answer is 0.4602. Okay, this is the meaning. Okay, here is 0. So 0.1 is somewhere here. Here is 0.1. Okay, this table, they read for this. Z is greater than, okay, small z, now is 0.1. So this is 0.1. Okay, so means, okay, z is greater than 0.1 is here. Okay, the area here is 0.4602. Here is 0.4602. This is the meaning. Okay, so this one, if you want to copy, also can. Okay, what's the meaning of this 0.1 and what's the meaning of this 0.4602? Okay. Okay, it's same as here, Okay. Okay, this value gives the properties of the standard normal distribution. Okay, this one must be bigger because all this table is only for, we call it upper tail. Okay, means on the right hand side one. Okay, so this one must be bigger. Okay, cannot be smaller. Okay, and then what is all this? 0, 1, 2, 3, 4 until 9, and then here again 1 until 9. Okay, what is all this? Okay, I will see one by one. Okay, you look at the remark here. Okay, each of this number is in the value of the third or fourth decimal place. For example, 4 means, okay, the 4 here, where 4? Okay, this 4 here means 0.0004. 19, where's 19? Okay, 19 means 0.0019. Okay, this one I will explain to you what's the meaning. Okay, let us see example. Okay, let's say 1, 3. Okay, just now is 0.1. Okay, now I want 0.13. Okay, how you read? 0.1 is here, and then you see for 3. Means this is the first decimal place, and then this is the second decimal place. So first decimal place you read from here, the second decimal place you read from here, and then the third decimal place you read from here. Okay, so if the question asks for 0.13, so 0.13, so this is your answer. Okay, so your answer is 0.4483. Okay, if I sketch the graph, okay, the graph actually do help, Okay, so come to a habit that always sketch the graph. Okay, so 0.13 is the number here, and then the area under the graph to the right. Okay, the 0.4483 is the area here. Okay, this area. Okay, this is the meaning. Okay, now how about this? 3, let's say 2. Okay, so now this is the third decimal place. Okay, so 0.13 and then 2. Okay, so you come down here, you come down here, come down here. Okay, 8. Okay, subtract mean minus. Subtract mean minus. Okay, minus 8. Okay, so you got to read 0.13, this number first, and then subtract 8 from here. But this 8 follow this. If this is one digit, 8 means it's at the fourth decimal. Okay, so what's the meaning? Okay, so this one means, okay, 0.13, they give you 0.4483. Okay, this is 0.13. Okay, then for 0.132, okay, you got to minus because subtract. Okay, subtract 8, but it's not 8, it's 0.0008. Okay, at the fourth decimal. Okay, how do you remember? Actually, it's very simple. You write in a vertical form. 4483. Okay, subtract 8. You just write at align with the last digit, the 8. Okay, then put minus, then fill out with others with 0. Okay, this is how I do lah. Okay, easy to remember. Okay, so the answer is what? 4483 minus, okay, 4475. Okay, so how about this? 13, 13. Now let's say 13, 136. 136. Okay, so same thing. 136. 6 is here. So you could now got to minus, subtract 24. Okay, so here you say if 2 digits means it's the third and the fourth decimal place. Okay, so now first we read 0.13. Okay, 0.4483. Okay, so 0.4483. Okay, 83. Okay, this is 0.136. Okay, so subtract 24. Same thing, I align with the last 2. I write the 24 minus. Then the rest I fill out with 0. This is how I do. Okay, so this one go to minus 0.0024. Okay, then answer. Okay, so the answer is 4459. Okay, then you will ask maybe, why subtract? Why minus? Why don't plus or others? Okay, why you want to subtract? Okay, you see the how to say? You see the concept here. Okay, now we compare 0.13. Okay, 0.13 is 130 actually. Okay, and then compare with 0.132. Okay, 132, 0 is here. 0.130, 0.132 should be on the right hand side. Okay, because it's a bigger 132. Okay, on the right hand side, okay, of the 0.130. Okay, then if you look at the area, which one will be bigger? Okay, the area is the area from that line towards to the right hand side. Okay, this one is bigger lah. The area is bigger. Okay, the area for 0.130 is bigger than the area for the 0.132. Okay, therefore you see 13 and the 132. Okay, you see the area. Okay, this one is bigger. Therefore you got to minus. This is the reason. Okay. I hope you can understand. Okay, maybe I ask a few questions before we continue. Because the standard one, okay, not that. Okay, and then this one you must know. Okay, this one I want you to copy also. Okay, for z greater than a is equal for the is equal to the probability for the z smaller than negative a. Okay, because this is symmetry. Okay, so when the question asks for this ask for this area, you cannot get the value inside the table. You got to convert it into this. Okay, let this is equal to this, and only you will read from the table. Okay, so this one I want you to copy down. Okay, first of all, let us continue yesterday. Kritika, you banyak kali ya. Okay, come, you answer the question first.
Okay.
Okay, come, you look at this. Okay, what is the value for P? Okay, probability for Z greater than 0. Hey.
0.5.
Yep, thank you. Okay, be confident 0.5 correct. Okay, next, I don't call you again afterwards. You get ready. Okay, Vanessa.
Yes, teacher.
How about this? Probability for the Z smaller than 0. Sorry?
0.5.
0.5. Okay, thank you. Okay, Nick. Hanis. I have to open this. Okay, look at my table. Okay, this one I already sent to you. Everyone must have this. Hanis is here. You Hanis. Okay, she don't. She didn't. Okay. Come, answer my questions. The rest also can try. Okay. I hope can see clearly. Cook a bit. Okay, maybe I don't want this. Can I change questions? Okay, I change to 4. 0.4. What's the answer? Okay. 4840 0.4 How you get 4840? 4840. Okay. This one you read from this. This one is 0.04. Okay. Your answer for 0.4840. This is 0.04 because this is 0.0 and then 4. Okay, one more try. Hanis? Okay, 0.3446. Because 0.4 is here. Okay, so the answer is 3446. Okay, critical. Critical.
0.2877.
2877. Okay, 0.56. So you read from here. Okay, 0.2877. Next, Farah. Hey, sorry. Okay, Farah gave me answer already. I think maybe she opened her copy. Okay, her answer is 4067. Okay, let us check. 0.2 is here, 3 is here. So I have a 0.4090. Okay, and then 6. 6, I go some more, I go some more, I go some more. 6 is 23. Therefore, I need to minus 23 from here. Okay, I think her answer is correct. Let me check. 4090 minus 23. Okay, correct, Farah. Very good. So I hope the rest also can know what to do already. Okay, so I go back to the textbook. Okay, the 0.235 I don't try already. Okay, we go to B. Okay, the 235. Okay, so you read from here 0.2, then 3, and then 5. So subtract 19, okay, which is 0.0019. Okay, then you get the answer. Okay, so I go to this. Okay, you look at these all tips. Okay, look at this one. Okay, sketch a standard normal graph first before determine the probability from the standard normal distribution table. This one always I will do. Okay, you see all the question, all the example here, they will sketch the graph. Okay, only you will know actually what you need to do. Okay, what adjustment you need to do. Okay, so sketching this graph, even though you see my drawing very ugly, but it helps. So I hope when you do also you can practice this. Okay, number 2 here. Okay, the standard normal distribution table only give the value of the area to the right tails of the graph. This one I mentioned already. Okay, it's on the right hand side. Start from the line that you draw. Like example, this is the line you draw. It's on the right hand side. This one we call it right tail. Okay, so we look at B. Okay, how to do this question? Okay, just now I asked you to copy this. You still remember? Okay, so I want to make you of this. Okay, if you draw out the diagram, okay, you see Z is smaller than negative 2.122. So you draw a line negative 2.122 because it's negative. So this line had to fall on the left hand side of the y-axis. Okay, here is the z-axis lah. Okay, so z is smaller than, therefore they take the left hand side of the line, negative 2.122. Okay, so you see, because of the the graph is asymmetric, therefore this is equal to this. Actually this one and this one is same thing lah. Okay, the graph and this idea is the same thing. Okay, so this is a right deal already. Then here for this one, you can read from the table. Okay, so actually you are reading for this. Okay, so you see, z smaller than negative a is equal to z bigger, greater than a. So z greater than, without the negative, 2.122. So this one you read from the table. Okay, so the reading from the table one, I don't go repeat already. I just want to teach you how to adjust. Okay, so that you can read from the table. Okay, so I go to C. How about this? Okay, by drawing the table, you see, by drawing the graph, you see, okay, same thing, negative 1.239, okay, so you draw the line is at the left of the y-axis, okay, then z is greater than, okay, compared to just now. Just now that question is z is smaller than, so the area is on the left. Now z is greater than, so the area is on the right, okay, but the same thing, okay, because your table is only give you the value, start from the 0 onwards. They don't give you the value for the negative, even though this is the right deal. Okay, so what you have to do? You got to do 1 minus the empty one here. Then you get this, because the whole graph is 1. Okay, so you get to do 1 minus, okay, this one. The empty one is on the left, so smaller than. Okay, then one more time, you're going to apply this. Okay, the z smaller than negative is equal to z bigger than positive. So change this into this. So the whole thing will become 1 minus, okay, for z greater than 1.239. Then this one, you can read from the table. Okay, then remember 1 minus whatever you get from the table, then that one is your answer. So you see, different types, The A is a simple one. Okay, B, okay, then C, then D. Okay, all are different types. So all these you got to know how to do for every of these example. Okay, from A until H. Okay. Okay, now we come to D. Okay, same thing, 2.453. Okay, because it's positive, so you draw the line on the left-hand side of the graph. Okay, then smaller than, then you shade the left-hand side from the line. Okay, so how? Because the table don't read the left tail, the table only read the right tail. Okay, but you see, I can do 1 minus the white color one, the empty space, then will give you the answer. Okay, so 1 minus this white color one. So 1 minus z greater than 2.453. Okay, then same thing, this one you can read from the table. Okay, after you read from the table, 1 minus, then that one is your answer. Next, we go to E. Look at this. Okay, how about this? From 0 until 1.236. Okay, from 0 until 1.236. Okay, so 0 is, remember, is at the axis there. Okay, 1.236, because it's positive, so we draw a line on the right of the y-axis. Okay, the area is in between. Okay, then how you make use of the table? Okay, the table can read this. Okay, the one I put dot. Okay, then see, this is half, so it's 0.5. 0.5 minus the dot. And you answer. Because the Okay, can you hear me?
Yeah,
What happened just now?
you were lagging.
I'm lagging, is it?
Yeah,
Okay, until where y'all can hear clearly?
the 0.5.
0.5. You mean the 0.5 minus? Still at E, is it?
Yeah, still at E.
Okay, so I repeat the E. Okay, okay, look at E. Okay, so you just use 0.5 because 0.5 is half of the graph, then minus the dot 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 part, then you will get the answer. Lor. So this dot 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 part is the one that you can read from the table. Okay, so this is the one you can read from the table. Okay, so 0.5 minus the one you read from the table, then that one is the answer. Okay, now we still have three more. Okay, how about this? Okay, in between a negative value and a positive value. Okay, so you sketch out the graph. Okay, like negative value, you draw a line on the left. Positive value, you draw a line on the right. So the area in between. Okay, so you see, I can't read this from the table. I can't read this from the table, the one in between. But I can read this. Okay, right till. And then I can read this if I change this, okay, because I know that, okay, z smaller than negative is equal to z is bigger than positive, okay, which is 0.461, this area, okay. So you just use 1 minus the dot dot dot, the dot dot dot, then you get the answer. Okay, so you see 1 minus this and this. So these two you can read from the table. Okay, then you get the answer. Now we look at G. Okay, for G, okay, modulus, what's the meaning of modulus? I hope you all still remember. Okay, for the G and the H, okay, both also are modulus. Okay, for this, the modulus, how? Maybe I write for you here. If you have, sorry, greater than A, okay, the meaning is, okay, Z is greater than A, and, okay, Z is smaller than negative A, okay. This is for the G, this one maybe you want to make a note, okay. Then this is for the H. For Z is smaller than A, then this one will be in between, okay, negative A. This one you have learned, I think during your form 4, okay. So recall a bit lah. Okay, so these two you must remember. Okay, so you see if greater than, then z is greater than A, and then also z is smaller than negative A. Okay, so if you draw out, okay, greater than A, so to the right, smaller than negative A, so to the left. Okay, so you see, because this big, I mean the size, okay, is same size with this. See, so this one you can read from the table. Okay, so you just double up 2 times. Okay, this one you read from the table. Okay, just times 2, then that is answer. Answer ready? Okay, for this is quite similar to this one, the F. Okay, so you use 1 minus these 2 portion, and but for this, because these 2 portion, the dot 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 one are the same size, so you can double up. So you just use 1 minus, okay, 2 times, okay, this one you read from the table. Okay. We still have like 10 minutes more. Okay, now we want to try to use calculator. Okay, after you learn the concept already, okay, now I want to teach you how to use a calculator. Okay. But my calculator here is the silver color one. I think mostly you all having the black color calculator. You take out your calculator, get ready. I don't know the silver color one is how. mode. Yeah, I tak pandai use this one. Okay, let us go to the black color one. Okay, maybe I write the step here. Yeah, what's happened? Okay, for this, this one, the calculator, I don't know which model is this. Manual 7 and then 2. I don't know which model. Okay, let's say now we are mostly are using the black color calculator, 570 ms. Okay, so I write out the step for you. Okay, let's say now we want to find this. Okay, you press mode 2 times. Okay, and then you see SD as 1. Okay, you press 1. Okay, SD stand for standard deviation or what? I'm not sure. Okay, and then after that, you press Shift 3. Okay, when you press Shift 3, you see for the shift actually for the number 3 is DISTR, distribution. Okay, you press Shift and then 3. Okay, this one stands for DISTR. Okay. Okay, after that you will see this. This one will give you okay, something like this. This one I'm not sure what is this. Okay, then you remember that day I gave you the notes. Okay, I call out the notes. This one. Okay, at the bottom of the second page you see this. Okay, I write calculator. Okay, P, Q and the R. Okay, this one matching with this, the P, Q and the R just now in the calculator. What's happening? Okay, this is 1. This is 2. And this is 3. Okay, so if this is right tail, mean this is the one always we read from the table. This is right tail, then you choose 3. Like just now that questions. I copy the question here again, sorry. Okay, this is a right tail. Okay, so you press 3 long. Okay, then it will come out R open bracket. Then you key in the number. Okay, 0.756. Okay, then they will give you the answer. Okay, the answer is 22482. Okay, anyone have a problem in using a calculator? Anyone cannot get the 0.22482. Must take out your calculator and try. Unless you really don't want to use a calculator, you want to use the table. Because you want to use a calculator also, you need to remember all this. You need to remember how to press a calculator, and then you need to remember what's the meaning of the R, what's the meaning of the P, and what's the meaning of the Q. Okay, so the P actually is a left tail. Okay, and then the Q is in between the 0 to the right hand side. Okay, so you can try lah, huh? Okay, one you try to use the table, and then one you try to use a calculator. Okay, the value may be different a little bit, but will be very close lah. Okay. Okay, I think that's all. I only have 7 more minutes. Okay, you see how this part actually can drag a few more periods. Okay, because after we need to read the other way around. We need to the question will give you the area, and then you got to read the Z. And then after that, then we have the solve problem, then finish. Okay. So if no question for me, okay, we will come to what you have to do for your homework. Okay, for this exercise, okay, you only do this question, this question. This one cannot. I don't know you can do apart or not. Okay, if you can do, this means you can do this. You can do this, 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 this. This one cannot. Okay, this one cannot. 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 Okay, so you just do extra 1, 2, 3, 4, 5. Okay, 5 more here. Okay, so I repeat, question 1, question 2, and question 3. You can do 5 questions. Okay, so that's all for today. Okay, I will dismiss you 5 minutes earlier. Okay, wait, I stop recording.